Our lesson today is the student will be able to find and use unit rates and unit costs. A couple of vocabulary terms today. First, we have a rate. A rate is a ratio involving two quantities in different units. For example, 150 heartbeats in 2 minutes. Notice the two different units. Heartbeats is one unit, minutes would be another unit. So it's a comparison that is of two values using different units. Second vocabulary term, unit rate. That is the rate for 1 unit of a given quantity. The denominator will always be 1. A unit rate is a comparison to a quantity of 1. So if we take that original ratio of 150 heartbeats in 2 minutes, we write that as a unit rate. We divide 150 by 2. That gives us 75 heartbeats per minute. The unit rate has to be written with a denominator of 1. By definition, unit rate is a comparison of two quantities using division, but the denominator must be 1. Unit cost is the third vocabulary term we'll use today. The unit rate that gives the cost per unit. All right, let's continue. Our first example, a box of wheat crackers contains 6 servings and has a total of 420 calories. Find the calories in 1 serving. All right, we want to find the unit rate because the calories in 1 serving, the denominator will be a 1. So I first take the ratio that I'm given, 420 calories in 6 servings. We want to make an equivalent ratio using a denominator of 1. That will be our unit rate. To make an equivalent ratio, we'd have to divide 6 by 6 to get 1. So the numerator would also have to be divided by 6 in order for the ratios to be equivalent. So I take my 420. I want to divide 420 by 6. 6 times 7 is 42. Subtract, I get 0. 0 goes in our quotient, and we wind up with 70 calories, right? 70 calories in 1 serving, right? And that is our unit rate, right? Unit rate must be written as a ratio with a denominator of 1. Let's take a look at our second example. It says to find a unit rate for $2.37 for 3 pounds of grapes. Once again, I like for my students to write the ratio that's given. So that would be $2.37 for 3 pounds. We want to write an equivalent ratio with a denominator of 1. To write an equivalent ratio, we'd have to divide 3 by 3 to get a denominator of 1. To make an equivalent ratio, we have to divide the numerator by the same amount. So I go to the side of my paper and I take $2.37 and I want to divide that by 3. 3 can't go into 2, but 3 goes into 23 7 times. 7 times 3 is 21. Subtract, I get 2. Bring down to 7. 3 goes into 27 9 times. 9 times 3 is 27. Subtract, we get 0. So we wind up with 79 cents per pound. That would be our unit rate. Let's continue. We want to compare which is a better buy. We have 2 sizes of sports drinks. They're shown to the left. Which size is the better buy? Round each unit cost to the nearest cent. Well, if you look carefully, one picture says that we have 32 ounces cost $1.29. So I want to write that as a ratio. So I take $1.29 and that's for 32 ounces. We want to find the cost for 1 ounce. I want to find the unit rate. To find the cost for 1 ounce, we have to divide by 32. So I have to take my numerator, divide by 32. So I do some long division. 32 is my divisor. $1.29 is my dividend. 32 can't go into 1. 32 can't go into 12. But 32 can go into 1 $4.29. That's going to go what? Possibly 4 times. 4 times 2 is 8. 4 times 3 is 12. I subtract and I get 1. So that's going to be about 4 cents for 1 ounce, right? Because we're rounding to the nearest cent. So that'd be 4 cents for 1 ounce. Let's change colors here. The other drink has 24 ounces for $1.20, right? So drink number 2 is $1.20 for 24 ounces. We want to find the cost for 1 ounce. All right. So once again, we have to do some long division. This time, 24 is my divisor. We have what? $1.20 is my dividend. 24 can't go into 1. 24 can't go into 12. But 24 goes into 120 5 times. 5 times 4 is 20. Subtract. 5 times 2 is 10. Plus 2 is 12. Right? So I get 5 cents per ounce. So what's the better buy? The better buy has the lower cost per ounce. So the better buy would be the $1.29 for 32 ounces. That's a better buy because you're paying 4 cents for 1 ounce as opposed to 5 cents for each ounce. Let's take a look at our next example. You can buy 6 ounces of yogurt for 68 cents or 32 ounces of yogurt for $2.89. Find each unit cost, which is the better buy. All right, so our first example, we have 68 cents, and the 68 cents is for 6 ounces. We want to find the cost for 1 ounce. Right, those are ounces. So I have to take 6 and divide it into 68 cents. Decimal point goes on our quotient. All right, let's do that again. It's a little sloppy. All right, I'm going to have to take 6 and divide that into 68 cents. 6 can't go into 0, but 6 goes into 6 one time. 1 times 6 is 6. Subtract, you get 0. Bring down the 8. 6 goes in 8 one time. 1 times 6 is 6. Subtract, I get 2. If I add another 0 and bring it down, that's going to be a 3. So that's about 11 cents. Right, 0.11. About 11 cents per ounce. Change colors. Our other example says that for $2.89, we're going to get 32 ounces. So we want to find the cost for 1 ounce. Right, so we'd have to divide by 32. Right, so I'm going to have to divide by 32. So on the side of my paper, 32 into 289. Decimal in our quotient. 32 can't go into 2. 32 can't go into 28. But 32 can go into 289. How many times? I don't know. Well, 3 goes into 28 about 9 times. 9 times 2 is 18. Carry the 1. 9 times 3 is 27. 1 is 28. Subtract, I get 1. So we're at about 9 cents per ounce. Well, what's the better buy? Well, 9 cents for 1 ounce is less than 11 cents for 1 ounce. So here's your better buy. $2.89 for 32 ounces would be your better buy because you have a lower cost for every ounce. Next page. A car travels about 25 miles on 1 gallon of gas. About how far can the car travel on 8 gallons of gas? Well, we're given a unit rate of 25 miles on 1 gallon. We want to know, well, how far can that car travel on 8 gallons? Right? We're using equivalent ratios. I'd have to multiply the denominator by 8. To make an equivalent ratio, we'd have to multiply the numerator by 8. 25 times 8 gives us 200 miles for 8 gallons of gas. That would be answer D. We continue. Write the unit rate as a ratio, then find an equivalent ratio. All right. For part A, you earn $5 in 1 hour how much do you earn in 5 hours? So if I'm doing A, I write $5 for 1 hour. There's my unit rate. I want to know how much would I earn in 5 hours. To make an equivalent ratio, we'd be multiplying the denominator by 5. So we want to multiply the numerator by 5 to make an equivalent ratio. That's going to be $25 in 5 hours. Part B, 25 words in 1 minute is your unit rate. We want to make an equivalent ratio to find out how many words, right, we would write or type in 10 minutes. We'd have to multiply the denominator by 10. So we'd have to multiply the numerator by 10 to make an equivalent ratio. 25 times 10 would be 250, and that'd be 250 words in 10 minutes. We continue. An adult's heart beats about 2,100 times every 30 minutes. A baby's heart beats about 2,600 times every 20 minutes. How many more beats does a baby's heart beat in 60 minutes than an adult's heart? All right, well, we could do this problem a couple different ways. We can find the unit rate, or we can make an equivalent ratio. Let's use equivalent ratios for this problem. So if I have the adult, right, the adult heart, 2,100 in 30 minutes, I want to know how many it beats in 60 minutes, right? This is times 2. To make an equivalent ratio, we'd multiply by 2. That's 4,200 beats in 60 minutes for the adult. For the baby, right, we'll do that over here. For the baby, there's 2,600 times in 20 minutes. We want to make an equivalent ratio for 60 minutes. That would be times 30. So numerator would have to be times 30. And what's 2,600 times 30? Let's see. 2,600 times 30 would be 26 times 3. That's 60 and 18. That's 78. And then that's, let's see, 7, 8 in 20 minutes. So 7, 8, and then, let's see. Oops. I made a little mistake because this is times 3. So this is times 3. Right? So to make that equivalent ratio, that's times 3, and that's going to be 7,800. How many more beats does a baby's heart beat in 60 minutes? Well, a baby's heart beats 7,800 beats in 60 minutes. The adult's heart beats 4,200 beats in 60 minutes. We need the difference of 7,800, 4,200. That's 0, that's 0, that's 6, that's 1. So 1,600 more beats. Right? More beats. 1,600. Sorry. 7 minus 4 is 3. Right? So 3,600 more beats would be our answer there. Right? We continue. A hummingbird's heart rate while resting is about 7,000 beats every 30 minutes. How many more beats does a hummingbird's heart beat in 60 minutes than a human baby's? Well, we know a human baby's beats what in 60 minutes? 7,800. So let's write that over here. Right, the baby is 7,800 beats in 60 minutes. 60 minutes. So let's figure out the hummingbird, right? So the bird is 7,500 in 30 minutes. Oops. 7,500 in 30 minutes. We make an equivalent ratio. An equivalent ratio for 60 minutes. That would be times 2. So that's times 2. 7,500 times 2 would be 15,000 beats. Right? We need the difference of 15,000 and 7,800. So we subtract 15,000 minus 7,800. That's going to be 0, 0, borrow, rename, that's 2, borrow, rename, so 7,200 more beats. More beats for the bird's heart, the hummingbird's heart, than a baby. Next problem. Boxes of fruit snacks are on sale at the grocery. The boxes are the same size. A family needs to purchase 24 boxes. Which snack should they purchase if they want to spend a lesser amount? Well, let's take a look at the first box is 3 for $5. They need to purchase 24. Well, 3 for 5, if I make an equivalent fraction with a denominator of 1, all right, 3 boxes for $5, all right, let's see, so I need to divide by 5, so I take 3 and divide by 5, so I take 5, divide that into 3, that's going to give us what? Right, 60 cents for one box. We now need that cost for 24 boxes. All right, a family needs to purchase 24 boxes, so we make a new equivalent fraction by multiplying our unit rate by 24, and when we multiply that unit rate times 24, right, 24 times 0.6, that's going to be 6 times 4 is 24, carry the 2, 6 times 2 is 12, and 2 is 14, 1 decimal place, so that's $14.40 for 24 boxes, right? That's the first one. The second one is a little bit easier, right? The second one, we have 4 boxes for $6. We want to know what's the cost for 24 boxes. All right, well, 24 boxes, right, that's going to be oh, I should have, let's see, I messed that up. Let's redo that. I just realized something, right? Let's redo that. 3 boxes for $5. We should just make an equivalent ratio for 24 boxes, right? 3 boxes for $5, we need 24 boxes, so that would be times 8. 3 times 8 is 24. Make an equivalent ratio, times 8. 5 times 8 is 40. So it would be $40 for 24 boxes here. If I look at the other box, we have 4 boxes for $6. I need to make an equivalent ratio for 24 boxes. This would be times 6. So this would be times 6, right? That'd be $36 for 24 boxes. Which one would be less? Right here, it would be less because they would only have to spend $36 instead of $40 for 24 boxes. How much would they save? They would save the difference between 40 and 36. So they're going to save $4. All right. A runner is training for a half marathon. Her training schedule is shown in the table. All right, here's our table. Right, which day did she run the fastest? Well, we're asked to graph and label the unit rates for each day on the number line. Well, let's first start by finding the unit rates for each day. All right, so let's start with Tuesday. For Tuesday, we have 38 seconds for 4 miles. Right, or 38 minutes. I was going to say that'd be pretty fast. 38 minutes for 4 miles. Right, 38 minutes, miles. So we divide 38 by 4. And we'll do that here. 4 into 38. 9 times 4 is 36. Subtract, we get 2. So that's 9.5 because that'd be 9 2/4. So Tuesday would be 9.5, and that's 9.5 minutes for every mile, right? So if I'm making an equivalent ratio, that would be 9 and 1/2 minutes for every, let's see, 9.5 minutes for every mile, every 1 mile. That would be our unit rate with a denominator of 1. That's Tuesday. Gonna run out of room. For Wednesday, we have 72 miles. That is for 72 minutes for 6 miles. Make an equivalent fraction with a denominator of 1. So for 1 mile, right, we divide by 6. So 72 divided by 6. Right, that's going to be 12. So that's 12 miles. Or that's 12 minutes for every mile. So 9.5 minutes per mile on Tuesday, 12 minutes per mile on Wednesday. Let's look at Thursday. Thursday we have 37 minutes and 37 minutes, 4 miles. We want to make an equal fraction with a denominator of 1. Right, 1 mile, 37 minutes, so I divide 4 into 37. 9 times 4 is 36. Subtract, I get 1. So that's 1 over 4. So that's 9 1/4 minutes for every mile. Right, 9 1/4 minutes would be faster than 9.5 minutes for the quarter mile. So that's pretty fast. Right, let's try Friday. Try to squeeze that in here. Friday. Or we don't have Friday. Oops. We have Tuesday, Wednesday, Thursday. Guess she took off Friday. So we're going to go to Saturday. And for Saturday, we have 31.5. Those are minutes. And let's see, 31.5, 3 miles. We divide 3 into 31.5. Right, that's going to be 3 times 1 is 3. Subtract. We get 0, bring down to 1. That's a 0. Bring down to 5. So that's 10.5. Right, the unit rate here for Saturday would be 10.5 minutes for every mile. And then finally we have Sunday. Right, I'll do Sunday down here. Sunday. For Sunday, we have 138 minutes. 138 minutes, and that's for 12 miles. We need an equivalent ratio for 1 mile, so I do some long division. 12 into 138. 1 times 12 is 12. Subtract, I get 1. Bring down the 8. 1 times 12 is 12. Subtract, I get 6. Remainder of 6 over 12 would simplify to 1/2. So that's 11.5 miles per minute. So I'm putting these values on the number line. Right? If I'm putting these values on the number line, we would have to start with the smallest, which would be 9 1/4. Right? So this would be, let's see, 9.5 is the lowest. So let's do 9. Let's make this 9. So this is 9 1/4, and these will be quarters. So 9 1/4, 9 1/2, 9 3/4. That's going to be 10, 10 1/4, 10 1/2, 10 3/4. That's 11, 11 1/4, and here's 11 1/2, right? And that's our highest. So the lowest would be what? 9 1/4. 9 1/4, this would be Thursday. Then we have what? 9 1/2 is Tuesday. So this is Thursday. All right, here's Thursday. This would be Tuesday. Then we have what? Let's see, we have, looks like, oh, Saturday, 10.5. So 10.5 would be here. That's Saturday. Then we have, what, 11 and a half. 11 and a half is Wednesday. And then actually we have 12. So 12 would be all the way over here, right? This would be 12. And 12 would be, 11 and a half was Sunday. Oops. Let's fix that. 11 and a half was Sunday. And then the 12 is Wednesday. All right. Well, that's the end of our lesson today. Hopefully that was helpful for you guys. So, catch you next time.